Hi, Mick McQuaid here again with part 2 of chapter 1 of our textbook, R for Data Science. And in this one, we're going to look mostly at faceting, and just capitalize that. And first, there's a short section called Common Problems that's immediately follows the aesthetic mapping section. So you should be sure to read over that and note things like you need to make sure you match parentheses, make sure you match quote marks, make sure if you see a plus at the beginning of the line on the console that you realize that R thinks you haven't finished typing your expression and is waiting for you to finish. Here's a really common problem that I've had. It looks better to me to put the plus sign at the beginning, and that's wrong. You have to put the plus sign at the end. If you look at all the examples here, you'll see the plus sign is at the end. If you don't put the plus sign at the end, R will think you've finished the expression and will try to render it immediately, often with surprising results. So be forewarned about that. Even though it looks better, don't do it. And there are a few other good things there. Okay, facets. So one thing that we can do besides aesthetics to add variables is to use facets. And this is particularly good for categorical variables. So anytime that you see categorical variables, you should think of that as an opportunity to use facets, which are subplots that display a subset of the data. So here's an example of one, and here's the code for it right here. So let's just run that in our console, and let's look at it. So this is using the facet wrap function, and that's used for one variable. So the variable that we're faceting on is class. So we have one subplot for each class of vehicle. And in each of the subplots, on the y-axis we have highway, and on the x-axis we have displacement. And we might instead want to facet by two variables. So we can use the facet grid instead of facet wrap to do that. And there's an example here. I'll just run this. And here it is. What we've done is put facets for the number of cylinders as the columns, and for the drive type as the rows. So we have one subplot for every combination of number of cylinders and drive type. So here are all the 6-cylinder cars that have rear-wheel drive. It looks like the most numerous cases are 6-cylinder cars with front-wheel drive and 4-cylinder cars with front-wheel drive. Although there are plenty of 8-cylinder 4-wheel drive vehicles here as well. And we could be having an overplotting problem here. I'm not sure about that. We could jitter these points if we wanted to, also to see if there's an overplotting problem. Okay, so one thing I want to do is flip this. So instead of these being the columns, these will be the rows. So that's the very next thing that I've done here. And we'll be asked about this flipping and which looks better. And I think the previous one looks better than this one. Okay, and then we have some exercises. And the first exercise is what happens if you facet on a continuous variable. And so let's do that. Let's facet on a continuous variable. And what happens is we get a lot of facets. Okay, so be careful if you facet on a continuous variable. Luckily, you know, we've only got whatever it is here, looks like about 20 or so. But you could wind up with lots and lots and lots of tiny, tiny, tiny facets. Question 2, what do the empty cells in a plot with facet grid by drive by cylinder mean? So that's these empty cells here. and they mean that there's no car that has 4 cylinders. Among this sample of 234 cars, there's no car that has 4 cylinders and rear-wheel drive. That facet is empty. How do they relate to this plot? Okay, and this is a plot that we've seen before. Let's do it again. Is that number 2? Yeah. So this is a plot that we saw before, and if you recall, I said that we could have stacks of dots here. We don't know how many dots are here. As it turns out, there are, I guess there are 4 dots here, but we don't know that from looking at this plot. Also, we have some areas that are empty. This is where any four-cylinder rear-wheel drive cars would be, and that's empty. So each one of these represents one of the facets. Each one of these represents one of the subplots. Each dot here represents a subplot in the plot that we saw. So that's the relationship. Okay, and then question number 3 is, what does this code do? And what does the dot in this code do? So you can see it says drive by dot here, and this is a facet grid. And the dot, all the dot does, it says whatever. So we're essentially making the facet grid into a facet wrap and doing it in 3 rows, one for each facet. We could just as easily do this in 1 row and turn these on the side and make these be columns by saying dot tilde drive. We're going to do something like that here. We're going to do that with cylinder. And here again, the dot just makes it be by one dimension. And we could just as easily do facet wrap. So here's an example doing it in facet wrap. And we get basically the same result. Okay, question 4. Let's see what's question 4. Take the first faceted plot in this section and talk about the advantages of using faceting instead of color and the disadvantages, and how the balance between these two might change if we had a larger data set. So in order to do that, let's just take a look at that plot. So this is that first plot that we looked at. And what we can see here are the groups really well, the individual groups really well, but we can't see the larger trend as well. So let's look at the color version to see the larger trend. And see the larger trend is much more apparent in this one, but it's much harder to tell what the groups are. So that's the disadvantages and advantages of those 2 plots. How would this be different if this were a larger data set? Well, probably if it were a larger data set, we would be able to see this macro pattern in the faceted plots better. So faceting probably would reveal even more of this trend. What else did I do here? Oh, no, that's just what we just looked at. Okay, so question number 5, read facet wrap. What does nrow do? What does ncall do? Okay, let's read facet wrap. Nrow and ncall both control the number of rows and columns. What other options control the layout of the individual panels? And there are quite a lot, so I'm not going to go into them individually, but you can look through this and see. You can easily parameterize this. Then why doesn't facet grid have nrow and ncall variables? Well, the reason, of course, is that the number of rows and columns in facet grid are controlled by the variables themselves. And speaking of facet grid, that's our next and last question. When using facet grid, you should usually put the variable with more unique levels in the columns. Why? And this goes back to what we were looking at before when we saw more unique variables in the columns or fewer unique variables in the columns. And it's your view, what you think, but I would agree that having the having more variables across the columns looks better, is easier to read, is more useful for reading, assuming that I have this kind of aspect ratio for the overall plot. If the overall plot were in the shape of an 8.5 by 11-inch page, that is a portrait orientation, then I would probably feel differently. Okay, so now that's it for faceting. And next we're going to talk about geometric objects, but we'll do that in a separate video. So thanks for your attention, and that is that.